I'm Mortaza Shahrzai. I'm a student in Germany, but I'm originally Iranian. And our project was studying the Twitter using the functions and the functionality of Mathematica. We developed our functions and packages to study how the people are tweeting on Twitter and what is the content of the tweets, and to study the public opinion about different ideas that is happening about politics, marketing, and other social and commercial phenomena. Hi everyone, I'm Mortaza Shahrzai, research assistant at University of Siegen in Germany, and I'm extremely glad I found this opportunity to just present the result of our project on Twitter data analysis, and I'm extremely nervous as well. So this is the fruit of our effort at Research Center of University of Siegen, Focus, Shaping the Future. And in Focus, we believe in to shape a sustainable future, we need to move the boundaries of research from the conventional disciplines to interdisciplinary studies. And this project is started at August 2013 and is mainly coordinated by Dr. Simon Hegelish. He's here. And here I just want to give a brief overview of the project. You know, Twitter is one of the leading social media services that they are generally like the new phenomenon of the century. And it has more than 255 million active monthly users, and the users, they tweet more than 500 million tweets every day, so there are a lot of information on the tweets on Twitter. Just imagine 500 million tweets every day. And the early goal of the project was to study the behavior of members of Germany's parliament during the parliament elections 2013 on Twitter, to see how they behaved on Twitter regarding the elections and the competition that they had. But but we decided to design our own application because our integrated system, because we wanted to use the whole functionality of the Twitter's API. And after taking some successful steps just in Mathematica, we decided to run the whole application on Mathematica. And as I told, to use the whole functionality of the Twitter's API, we decided to concentrate on some specific aspects of the API. First, we decided to define some simple functions to just get connected to the Twitter's API easily with just simple functions. Then we decided, because there are a huge amount of information on Twitter, we decided to implement SQL databases to store our data in SQL databases. For the third aspect, we decided to just find some simple descriptive statistical tools to just show the information that the main content of the tweets that we are downloading just by simple statistics and simple descriptive plots and plots. The fourth goal was to use advanced statistics and graph theory analysis to find the most important connections and networks of friends and connections on Twitter. And the final goal was to find simple ways of efficiently clustering just huge amount of information that we are downloading from Twitter. Because there is just a huge amount of information, so we needed some tools to cluster the data just to get the main content of the tweets. And for this goal, we needed web access, open authentication, full SQL functionality, string and numerical data modification, statistical, algebraic, and scripting tools, and some other information that we could just find in, almost everything we needed within Mathematica. You know that there are just some sort of functions within Mathematica that you can use them for social media analysis, like for analyzing Twitter. But because we found the functions that are not enough flexible and they are not just, they don't use the whole functionality of the Twitter's API, we decided to start from the just from the starting point, we develop our functions and our connection and our, just we started to design everything by ourselves, not to use the functions of Mathematica, just to add more functionality and more flexibility to the functions. For this goal, we just designed 2 main packages that they have 3 main functionalities and a bunch of other functions. The main package is Twitter API package, which has 2 aspects, the dynamic use aspect and the static use aspect. Just to give a whole scheme of the package, you can see here the whole scheme of the package, how it works. The user sends a request by the functions that we have designed to API of Twitter, but this request should be authenticated by the user, just like something like username and password to make it like a valid request. Then the REST API, the Twitter's API, will respond to the request, and the downloaded information can be it will just come to the front end of Mathematica. We can just put it to Mathematica files. We can push it to the SQL databases, or we can just keep it on the front end for further analysis. The dynamic aspect of the Twitter API package, it works based on the same scheme as you see here, but the difference is when you just run a function for one time, then the function will just continuously work for infinite amount of time. You just can start using the function, and the function can work for months or years, and you don't need to just touch anything. I will just show you that the data will be just pushed to SQL databases, and you can just simply use them. And the second package is clustering plots package. This package just includes some clustering tools based on graph theory for clustering the tweets. And there are some functions to plot the result of clustering and, in general, the data that we are downloading from Twitter. I will just give sample of instances of the functions. So to start using the package, one needs to initialize two objects. The first object is the connection to the Twitter API. For this, we designed the function auth function that it needs something like a username and a password that on Twitter API it's called consumer key and consumer secret. So you provide these 2 inputs to the function, and it will just take a key from the website, from Twitter, and you can store this key in a file, and you can just use this key for infinite amount of time. So you don't need to every time just connect to SQL to Twitter API. Just you need to call this object from your hard disk drive or from your work directory. The second thing is to initialize the connection to SQL servers that you have. Again, we use the functions that we have in Mathematica, just using the database link package of Mathematica. And you just need to just provide the port, the username, and the password of the connection. Don't try to memorize the password. I've changed it. Okay, just I'm bringing some information, some sample functions from the static aspect of the Twitter API package. So we have this function here, grab timeline. This function just needs a name of a user on Twitter and some other inputs that are optional, just to download all the content from the timeline of a user on Twitter. Then you can just specify how many content you want to download, or you have some other input functions, input variables, and you have the connection authentication that you should provide to the function. But the fact is, this function is limited because of the limitation that the Twitter has just set on the access to the website. So you can just download 4,000 contents on the timeline of each user for each session. The second thing is search tweets function, which just searches the whole website on Twitter for search query. This one is a search query, actually not a name, a search query, and downloads the number that you want to have just content related to this search query from Twitter. It can be the content from any user on Twitter. And again, you have some optional arguments that you can supply just to to filter the input. the output. But the first two functions, they just bring the downloaded information to the front end of Mathematica. You can use this write search tweet function to write the result of the search to a Mathematica file. It's the same as this function, but the result, just after you run this function, the result will be saved on your work directory, it won't stay in the front end of Mathematica. You have write daily search tweet that writes the tweets that are related to your search query, and they are just for today, not for the past days. Sometimes you want to have some fresh data or something. And this function works the same as the previous function, but pushes the result to the SQL databases. But up to this point, and this function needs the SQL connection that you have initialized before. These functions, they are static functions. So you just once run them, and you just will have the result. Yeah. So as I mentioned, we started the project with the goal of studying the behavior of members of Germany's parliament during the elections of 2013, parliament elections 2013. And we just used the functions that I brought in the previous slide just to make the whole analysis, of course, just to take the data from Twitter. So we had 264 members of parliament that they had Twitter accounts. Here we just made some sample statistics just about the number of followers, friends, the number of contents that they have on different members. We just grouped the members, 264 members based on their parties. And here you can see some other information about how many times their content have been favorited, how many times their content have been retweeted. And to show the functionality of Mathematica, just this red line here indicates the election day. So you can see the members of different parties, how they use Twitter just before the elections and after the elections. So as sample, you see the members of party Lincoln, they just increased using the Twitter just to the election day. Then after the election day, they just dropped using Twitter, and it kind of makes sense. They just used Twitter just to reach people to just promote their party. And the point is, you can see in the weekends, they were just kind of, resting, or they didn't want to contact the people on the weekends. And here we can just change to see the graph of usage of Twitter of different parties. And you can see for all the parties, it's the same. They increased using, and after the elections, they just dropped using the Twitter. But the other point is in just content of some tweets, if the user has allowed the geolocation, you can see from which point of country or from which point on the earth the tweet is being just posted to Twitter. So from the tweets, we just made a graph, a plot actually, and to see from which points they have tweeted their content, from which point of the country. And to make this graph, we just told to Mathematica we need to have some cities on the plot. We didn't know the coordinates, of course. Then, where is the slider? Yeah. Then, just using the functions of Mathematica, we found the position of the cities on the map. Then, we brought the map of Germany, the smooth kernel distribution of the points that we had, and we made this graph. So this graph is whole content driven, and there is no image or something here. All the elements of the map, it's just content of Mathematica and the computations of the kernel density distribution. And you can see this just from which point of Germany the different members of parties, they just tweeted their content. And this map is just a combination of 7 layers. So it's whole content driven. There is no image or something in this map. And on this map, you can see the whole members of parliament, the whole members from which point they just tweeted, and the tags they showed. You just can see from a sample, this O is for Lincoln. So the party Lincoln, they used this. They were in these positions when they tweeted. And it's funny to see that the party SPD and the party, CDU, they were tweeting sometimes from outside of Germany. And, we had like more than 65,000 tweets that we downloaded related to our, from the timeline of the parliament members. And we just wanted to see how many times they have called the name of each other just on the content of on the content they have been tweeted. And, we just used this simple string pattern, and we looked for this pattern, which is just concatenated to the name of the members to see how many times they have called each other. So just using 2 lines of code, we just could analyze the whole tweets to see how many times the different members of different parties they have called each other. Then we have the dynamic use of Twitter API package. We have dynamic write daily search tweet. So when you run this function for a search query and you give a time interval, like 15 minutes, this function will be just executed every 15 minutes, and the result will be saved on a file just for a given name. So if the function is, just imagine, is just executed for 200 times in a day, the final result will be a just mathematical file with the tweets, but there will be no duplicates, and the function is smart in managing the traffic, the Twitter traffic, because there is a traffic, as I told you, traffic limit. So the problem was to control the traffic. And the other function is SQL dynamic write search tweet, which writes the result of the search to SQL databases. And just to show you how simple it is to make the function just dynamically used. So it was the static use function. We just put it in 2 lines of code in a dynamic module to make it just dynamic. So it was, the main point is to prepare this function. Then it's really simple to put it in just 2 lines of code to make it a dynamic function. And we have this function, SQL dynamic write search tweet, with both pushes the result to this. It's the same as this function. Sorry. Then we have I will just bring some samples for the dynamic functions. Then we have the clustering plots function package. It has 3 main, 5 minutes. It has 3 main functions for clustering the tweets and to make word clouds and to just plot the result of clustering. I should increase my speed. And we have another project on what is the public opinion of people on fracking, mainly in USA. So for this goal, we just run this function, SQL dynamic write search tweet, just to search the tweets about fracking and to push them to SQL databases. And we search for tweets that they have these keywords, fracking, earthquake, gas, and shale, just to get the relevant tweets. And every 15 minutes, the function is executed. And the point is we are using different authentications. So because we have many words and many words to search for, and the function is going to be run every 15 minutes, so we have a high traffic, so we should just give the function more authentication files, keys, actually. Then later from the SQL databases, using this function of Mathematica, we can go to this connection, this table, and this column, and find the tweets that they are for just related to just one specific day, because we needed to see just a sample here. I just decided to see what people were telling about fracking on this specific day. So I just went to SQL databases, this database, to find the content that I want. Then I just, because the text of a tweet is just as a whole a text. It's a sentence, but it's a text when you just download it. We needed to just break the sentence at the white spaces and at the characters, just to have the important words. And then we needed to just stem the words. So a sample, just fracking is destructing the environment. We should just estimate to frack, destruct environment. So destructing should be just stemmed to destruct. For this, we just, in the middle of, making our algorithm for stemming, I just found that the stemming function is already in Mathematica. Even for stemming the words, there is this function in Mathematica to use for stemming words. And we just made some sample, some matrices that we need for clustering, and we just use this function from the package to say we want to cluster the tweets that we have, 1,700 tweets that we have, to 9 levels, not 15, but 9 levels. And here we use this function to cluster them. And here you see here, it's the main data here. Then in the first level, it's broken to 2 splits. It's splitted to 2 clusters, and in each level, it's just splitted. And you just here can change as layout. You can see the most frequent words in the cluster below, or you can change it to see the word cloud of the words that they belong to this cluster, or you can change it. You can see for different clusters. You can change it here to see the list of frequent words, not the core term. We need this core term for clustering, so it's related to the algorithm. And we have some steps that we are just working on it. One is parallelization of the computation, because it's heavily it's really heavy. It has really heavy computations for clustering. We are going to just apply it, implement it on the cluster of university, and we want to implement accurate semantic analysis. We have already taken some steps, but there are some more steps to take for semantic analysis. And today I saw that Mathematica is doing something as well. And we are going to add more user interactivity to the plots and to the functions. That was it.